If you have a question or if something is not clear, please feel free to ask. Raise your hand. Again, there's no 100 people around here at the moment. It will be easier for me to answer to each one individually. So let's take advantage of this situation, right, before people come. So my name is Amit Schnitzer. And Amit is a previous conversation. Amit is also an Indian name, but in this specific meaning, it's an Israeli name meaning a friend. Just, just out of the curiosity of people, so I'm answering that. I've been with Checkpoint for 4 years, almost 4 years. It will be in February. And I've been around all this time around cloud. It started using the VSAC. And nowadays, it's all around the CloudGuard family of products. We'll talk about that. And this specific presentation I have is about the blueprint, the cloud security blueprint. It was meant specifically for public cloud. I wrote it almost 3 years ago. So there was it was born because I had conversations with customers, such as some of you, partners and the vendors themselves, and they all had the same question or challenge. The question was, how do we build the infrastructure on our public cloud in a way that is secure, but also in a way that our development and the business can thrive, can work seamlessly without all the obstacles that security brings into this mix? This is the question I will try to answer. And since this is the 3rd year that I'm presenting the blueprint, it has become a big thing by now. You can find it. I'll post at the end of the presentation. You'll have a QR code. Then you can download the updated document, because by now we're already at level or version 2.0 of the blueprint. Okay. So a little bit of the agenda. The first thing is we're going to talk about, what is the security blueprint, a recap of that, just to remind everyone about the architecture concepts in high level, not too much of a brain drainage. Second, I'm going to show you a demo, because some skillful people from within the SE community also automated the blueprint, so I'm going to show you how it looks like. And you can do that by yourself at home. We're going to talk about what's new, because the blueprint is almost 3 years old by now. But some things, they keep on moving on the cloud, right? Some cloud vendors introduced new features that collaborate, communicate, integrate, or we integrate with them as well. So the blueprint had to evolve. But the blueprint also evolved because there are new threats. Well, not new, but in public cloud, they become relevant. So now we have to respond to that as well. So the blueprint will keep on updating itself. Well, we actually updating it. But you guys, from your perspective, it's updating itself. Just go on the website, take the updated document, and get yourself updated. And then we're going to summarize. There's going to be 3 different demos during this presentation. First one is around the automation. Second is about a new feature that we introduced, the Geo cluster on Amazon. So I'm going to show you how to deploy that. And the last demo, if we'll have time, I don't suspect we'll have a problem with that, is I'm going to show you a live demo. So I'm taking a risk here. I'm going to show you a live demo of an Azure deployment. Well, I'm going to show it, so let's not ruin the surprise. This is a slide that we always have during events. Even when I meet customer, well, not this specific slide, but this slide usually has a lot of snippets taken from the news. A lot of snippets saying, this company has been breached, this company has leaked, this company has burned, something happened to them. And it's always around, well, in this slide specifically, it's always around cloud. Because someone forgot to encrypt, because someone by default left the EC2 machine open, someone forgot, someone did not understand, it's always the same thing. There's nothing special about it. And this is why I decided this year to keep this slide open. Because yesterday, there might be a new company that was compromised. It's actually pretty hard to keep pace with them. a few days ago. I think it was, maybe it's 2 weeks now. But I was before a presentation in another event, and I wanted to be updated. So even before going on stage, I read the news, and I was like, oh, Starbucks. They had an issue with an API key. One of the developers forgot the API key is exposed in the code. And again, there's no way I can update my slides beforehand. Take that as an assumption that 5 minutes, or even now, as we speak, there is a company being breached, and they're not even aware of this. So this is just to remind us all, this is exactly why we're doing what we're doing. I'm talking Checkpoint specifically for the last 26 years, and I'm talking specifically about our cloud business unit. All we do and all we care about, we are a security company. We've been that always. We will always be that for you. And our single mission is to make sure that you guys are secure. No matter where you are, where your assets are, where your data is, that's all we do. So that's what I want you to remember from this slide, although it's pretty empty. Have you seen this before? Can you raise your hand if you've seen it? Not many. Oh, maybe we should do the presentation from last year, before? No, or yes. Anyway, this is how the blueprint, the version 1 of the blueprint looked like. I'm going to invest a little time to explain because not a lot of hands were raised. And please, I'm begging you, if you have more questions about this later on, because I'm going to skip some stuff, I want to concentrate on the future, not on what was 2 years ago. Feel free to approach me, okay? Like I said, I was the one who wrote this, and I'm very proud of it, and I want to take the opportunity to conversate with each and every one of you if you want to, obviously. So basically about the blueprint, what you see here is a high-level design. It's by no means any technical. Well, it could be. So now I'm going to add some words that will make it a little bit more technical. What you see here is that it's based on a hub and spoke model. So you can see a hub here and multiple spokes connected to it. You can see a hub here and then multiple spokes, the same ones, by the way. And I'm going to tell you why it's like that. Those spokes, that's the crown jewel. This is where your business is. This is the assets or the data that you want to protect. The crown jewel is here, the spokes. And what we did, well, theoretically in this design, we wrapped everything with a wall or a fence or whatever you want to call it. How did we do it? We actually blocked all in and out communication to the environment, to the crown jewel, leading to the crown jewel and from it. And we forced it thus to go through the hubs. Think about the hub as like a junction, a big junction of traffic that all the traffic has to go through. And surprise, surprise, we've deployed Checkpoint CloudGuard IaaS. That's the checkpoint gateways that you can deploy on each and every one of the public cloud vendors, whether it's Amazon, Azure, Google Cloud, Oracle, IBM, any of them. We support and we're part of the marketplace. Of course, Alibaba is very relevant in this region. So Alibaba, obviously, we're also supporting. You can do this on Alibaba. So there is also a reason why there's 2 hubs. Although if you want to conversate later, we can argue or talk about how alternative designs are also possible. I've seen and had many customers saying, okay, you know, 2 hubs is too much, I need only 1, and then we designed it differently. It's possible. There were other customers saying 2 are not enough, we need better segregation. We did 3 hubs. And again, this is not time for that, but if any of you is interested, come later and I'll show you. I have slides, I have information, and I'm always happy to conversate. Okay, so what we did is with those 2 hubs, which is the reference architecture, this is what we recommend, is the North Hub is used for traffic coming from the internet. This is its sole purpose. This is like a DMZ in the old days of the network, the on-premise LAN, right? So this is the DMZ. Any traffic coming from the internet, we don't know where it's coming from, we don't know who's behind it, is going to hit those gateways here. And then only after they were approved by the policy and scanned with all the checkpoint blades in there, then we forward them to the appropriate spoke. Nothing else goes through that line. It is, And there's another reason for it. Usually, for many, many customers of ours, this line right here represents production, represents the stream of money, right? This is the business. If something goes wrong here, then if there's downtime, it means loss of money. So we've created another hub, and this hub, the South Hub, has a few more roles. So the first one is to be responsible for traffic going east-west inside the environment. Think about, let's say your web servers reside here, and your application servers are in Spoke 2. It's just an example, because there's many other options here. But communication between them will go through the South Hub, and again will be scanned. Take note, this kind of traffic does not interfere with the traffic coming from eyeballs, from the customers. This kind of traffic is different and could be scanned with different scanning mechanism, different blades, right? Because scanning traffic coming from the internet and scanning internal traffic is different. Even the nature of the traffic is different. This could be stateless, HTTP or HTTPS, and this type of traffic might be stateful. You'd be talking to a web server communicating to a database server, and this could be a stateful connection, not a stateless one. Another key thing for the South Hub is to and from corporate. A lot of organizations, I have not seen one actually. All of the organizations that I know of connect their cloud environment to their on-prem. They could be over VPN, or over MPLS, Express Route for Azure, Direct Connect from Amazon, etc. And some of them even do VPN on top of that as well, so that's an option as well. But even that path should be inspected. So the South Hub is usually the place you inspect traffic. And one thing you don't see on this slide, but I want to note, some things about the blueprint design that I wrote is not just about the features that Checkpoint provide you, which a lot of it is, but some things are just good practice of what to do in cloud environments, regardless of which product you're using. Obviously, if you're using the best like Checkpoint, it's great, but an example for this would be you can disconnect one of those lines. Let's say that Spoke 2 right here is hosting your database servers. There is no way in the world, I guess, that you would want this Spoke to be exposed to the internet. So in the regular design, you can have a policy here on the North Hub, on the gateways, that will block traffic to Spoke 2. It's valid, you can do that. But it's not enough. Because when we're talking about cloud security, public cloud security, misconfiguration could be a thing. Marina mentioned that before me, and a lot of people will mention it this week, and you'll see it. Misconfiguration is a big deal these days, because people don't necessarily know cloud well enough. They'll do some mistakes, and those mistakes will hurt them. They will be exposed back then. So if we disconnect this cable, well, it's not a cable, it's a connection. And yes, it's public cloud, but if we disconnect this connection right here between Spoke 2 and Hub, even if someone opens up, I don't know, it doesn't understand Checkpoint at all, right? And he opens up a rule that says any, except, no one from the internet will be able to go directly to Spoke 2 where your database is. It's like a two-layered approach, right? Any questions about that? Okay, this is an example of a systematic decision, architecture decision to take when you're in public cloud that helps you guard your environment. It has nothing to do with what kind of solutions you have on there. It's just a good practice that if you have a connection that you don't want to run around, then you just disconnect it systematically. Okay, we're ready to move on. So, and this is jumping like 2 years ahead, because this is showing how an initial construct, this is how a typical environment on Amazon would look like, typically, again. And you can recognize this North Hub, where traffic is incoming from the internet. And you can see the South Hub, where traffic usually is outgoing. So it could be outgoing to the internet. It could be outgoing, let's say, from this VPC, going through the transit gateway, going through the gateways of the South VPC, and then going to and from on-premise. So this is another option. And so this is a design that was built based on a change that Amazon introduced. I guess it was like 6 months ago, probably less. And this is what it is. It's the Amazon Transit Gateway. And so what we did is I just took the blueprint that I just showed you, the first version, and I customized it and made it possible to work with the Transit Gateway. It makes sense because now Amazon takes care of routing domains between VPCs, because in the older design, where on Amazon specifically, they didn't have the transit option. We had to do VPNs. It's a big deal. It's too much details for that session, I guess. But just so you know, now that we have the Transit Gateway, okay, so we just updated the construct. Now we have that as an option. And this is already running in several, well, a lot of customers by now. A lot of customers deployed the blueprint design on top of Amazon using Transit Gateway. Actually, we have a lot of customers deployed even before, so that's an interesting discussion as well. How do we move from the old design to the new one? Do we want to move? That's a question that our customers are asking. We're good with what we have. Why do we need to move? Well, it's a discussion. The answer changes. It depends on the customer use case. So what if I told you, this looks a little bit complicated. If you guys have any experience using the cloud, this looks like a big deal to set up, right? Do you agree? Okay. So what if I told you that one of our guys, I don't know if you know him, Richard Cove from Australia region, he took this initiative and automated using Terraform. Completely automated using Terraform. If you go on GitHub, you can actually get his code. It's publicly available for everyone. If you have Terraform, have any experience, even if you don't, it doesn't take more than 5 minutes, I guess, to learn what Terraform is. And you don't need to know a lot just to run the code that Richard prepared for everyone. And basically what it's going to do is going to run the entire environment. How does it look like? You want to see? So that's the first demo. It's not a live one. So we're going to copy the code from GitHub. You're going to do this at home if you want to, of course. It's really simple. It's just using git clone and then the link. And look what happens. It's just copying all the files, all the scripts. And now we're going to run it. Well, of course, we do need Terraform installed, but running it is really easy. Sudo terraform apply. I'm providing my password there. And it's going to run. This is going to take, this is a complete environment. There's going to be VPCs, subnets, gateways, 13 different instances in there because it includes also workloads that you can test, incoming traffic, outgoing traffic. It's the whole thing. Richard did an amazing job. And this thing, and like you see, I'm fast forwarding it because the whole thing might take up to 20 minutes. And by the way, what takes time is our management server to set it up because this is an environment that it's from A to Z, including the management server. If you already have a management server, it takes really less time because a gateway installation, I don't know if you know it, but a gateway installation today on public cloud takes several minutes. And I'm saying like 5 minutes is a lot because we're using Blink now. We have a new technology called Blink. Have you heard of that? Anyone? Okay, so Blink allows us to make it really fast. So using Richard's code, and yes, I did fast forward it, but think about 20 minutes. Within 20 minutes, you have that. And when I say that, you have machines, instances inside the VPCs. You have the capability, including DNS, if you like. If you have your own domain, you can register it. So you can have traffic coming from the internet to your web servers, just like I showed. It's the whole thing. So I'm suggesting you try it. Another thing to note, as in before, this VPC right here is considered internal. That's why I did not connect it to the North Hub. So this is just an example. It's really easy to set up using automation these days. You don't have to know how to run and implement one by one, configure it. There's a lot of configuration to do. A I'll tell you a small anecdote from my personal life, right? Since I work in Tel Aviv headquarters, R&D are using my skills every now and then. So the last time is about what we're going to see next. It's about the Geo cluster. So I'm going to show you in the next slide, but I want to tell you that R&D came and said, hey, we want you to test the new cluster. Yes? No, no. So incoming traffic goes this way. So the question was, what about the symmetric nature of traffic? And the answer is that using this design, traffic coming from the internet is going this way, hitting the VPC, and then when it comes back from the same place. So the request will get from... Yeah, yeah. So again, the question was, if traffic comes in from the internet hitting this VPC to a certain instance, and then this instance needs to initiate traffic, it's a new connection, and yes, if it's going to the internet, just I have not seen such an example, but it's okay. Traffic will be going through here. That's true, but it's two different connections. Yeah. Let's talk about it offline. Basically what we do, no, it's a valid point, and we've had customers with that concern. One option, just so you'll have it in the air, is to implement in the header the source IP. Sometimes it's okay, sometimes it's not good enough for you, so we can find a different option. Like I said, this is specifically just a reference architecture. This is the default. This is the standard that we offer to our customers. Some customers might say, hey, we have different requirements, and it's valid and it's fine. So even in the document that you have linked to download, you'll have, if I remember, maybe not on that specific document, but I am referencing to other alternatives, because some customers, they require different design. Yeah, definitely valid. If you want, we can talk about it offline in more details. So what's new? We're introducing, well, it's not up yet. It's in EA phase, but really last phases of EA. EA means early availability. We're talking about R80.40 version. So whenever R80.40 will become GA within Checkpoint, it will be also available for you guys on the marketplaces, on Amazon, on Azure. And what we're talking here is groundbreaking, in my opinion. Because what we're offering here, nobody has. What we're offering here is the option to create a cluster. And when I say a cluster, this is not what our competitors call a cluster. This is a true cluster that connections are being synced. If you go, if you try with someone else and they talk a cluster, they mean a load balancer that will send the traffic. We can do that, that's easy, but connections are not kept. If one of the gateways fail, you're gone. All of the connections on that gateway is gone. It's okay in some cases, I can talk to you about those cases, but some cases require a cluster. So we're introducing a true cluster that I have already, well, I'll show you another demo about this. And what's unique about it is that each one of the nodes within a cluster, in this cluster, resides on a different availability zone. Again, the traffic doesn't load balance from a load balancer. We can do that as well. It's an auto-scaling, regular. That's not what we're talking about. I'll tell you a small secret, right? I have a friend working for one of the competitors. He called me one day. He heard the news. He's Israeli. Everybody's talking to everybody, right? And he was telling me, do you truly have something like that? He wouldn't believe, and of course he was jealous, and I'm telling you the truth. This guy was all over the place. Like he said, I can't believe it. I can't, like he's my colleague, right, on the other side. But this is something that nobody else has. This is using our technology to sync traffic between AZs. This is something that is considered impossible at the moment. We do that. Well, so at the moment we support a cluster of 2. Which means if you have 3 AZs, it's fine. You can forward the traffic to one of those. But the cluster gateways will be reside in 2, either 2 that you will want. If it's something that is very important, we can talk about it and we'll find why you need 3. We can make it 3 for, it depends on the features, of course, but that's what it is. Yep. For each node? So that's a really good question. This specific cluster doesn't have a VIP address. It means that each gateway has its own IP. Again, it's more technical than I wanted or initially wanted to go into, but just so you know, the IP of the gateway is specific to each one of the gateways, right? It doesn't fail over. This is a key thing because later on you'll see that a failover takes, whenever one of them fails, is like 5 seconds. Okay, so in this design, if we can introduce a cluster, so we had a cluster before. Checkpoint has a cluster for, I think, 3 years on Amazon. But this cluster is kind of not complete because you'll have a cluster into one of the AZs. We're offering here multiple AZs. It means that you can keep the nature of the cluster, syncing connections and everything, but you can also be fully redundant from Amazon best practices perspective, because from their perspective, they say, if you want to be redundant, you should be locating your devices into multiple AZs. Because, I don't know how much you know, but each AZ is a different building. It's a different data center with different electricity feeds, different internet connections, so it's a geographically diverse building, right? Location, physical location. So if we can do this cluster, so we can now connect it, we can connect the internet on the other side. That's one option. So this could be the gateway leading to and from the internet. Another option, and whatever I'm showing you here, by the way, this is not my thoughts. This has already been done with customers. So even if we're talking about specifically the cluster, so this is still in EA, early availability stage, but we have customers already trying it. We also, this type of connection, this is called the service endpoint. So a service endpoint, you can connect the S3 bucket service by Amazon directly into your VPC. Do you know about that? So now we're talking, how does the CloudGuard gateways can help you secure PaaS services, platform as a service. And again, I'm showing you the next generation or the new stuff. We can talk about the blueprint, but now I want to show you where the blueprint went with this. So I've seen customers asking to connect the S3 buckets to the hub, and then they have control over who has access into their S3 bucket coming from the spokes. You can actually decide that the Windows machines from both can go, but Linux won't. You can do that using the policy. You can do a policy that says, of course, spoke A has access, spoke B doesn't. And you can have multiple options of controlling the traffic that goes to each bucket. I'll show you later that you can actually decide You can take actually more restrictive approach and then make sure that, for example, the S3 bucket is only in a certain region, for example, just using the policy. This is possible now. Another option, and another option that was used, is to connect your VPC. And again, your VPC in this example, of course you can connect it directly to the VPCs, but then where's the security in that, right? If you're connecting it to the hub, as I'm showing here, then traffic from spokes, and then you can add another spoke here, and then it will also just add to the mix. And in this example, we're using the private link, Amazon private link. In this example, we're connecting to a partner VPC. Maybe it's a SaaS provider. I've seen that. I'm not just making it up. There's a customer using this already. So a partner providing access as a service, software as a service, but now using the private link, he's providing private SaaS access to his services to that company, to the spokes. And this is where it's going. And when we're talking about the options, it's the same hub. The hub is like a junction. So traffic to and from anywhere that you want to be able to inspect, that you want to be able to monitor, because we're talking about not just inspection, we're talking about monitoring. We want to be able to see what's happening. We want to be able to have visibility. If you're going through the hub that has CloudGuard in it, then you can apply all of the blades, all of the protection capabilities you have with Checkpoint. And obviously you can have logs. And again, I'll show it to you later. Any question until now? Questions? None. Are you asleep or is it boring? Do you want me to continue? I can free you earlier if you want. No? It's just a rest before I continue. Okay. So this is how you're implementing the Geo cluster. And again, this is a video. I could have done it with you, but it's kind of, might be risky. I'm going to try it later with Azure. So first, this is the environment I created. So I have a Windows machine in one spoke. It's almost like the diagram you saw. This is the window. I'm actually logged into it. And you can see the IP address right here, 192.168.1.110. And you will see it on the diagram as well. So it's just a simple Windows machine that I started on Amazon. And now what I'm going to show you is I'm going to connect through the cluster to the Linux. Windows, cluster, Linux, all going through the transit gateway. So that's east-west traffic within the environment. I'm using PuTTY. I'm connecting to the Linux machine. I'm providing my key. Whoops, and I'm inside. And let us zoom in so you can see. Let's see what the IP address is. So you can see 192.168.200.100. I made it very simple. Okay, so here it is. So this type of connection was going through the firewall. How do you know that it went through the firewall? It could have gone this way, right? Without going through the firewall. How do we know? Well, we have visibility. We can actually take a look on the logs and find this connection right there. It's easy. So I'm going to filter the traffic. I'm going to find traffic coming from 192.168, the client, the Windows machine, 100.110. And you can see the RDP connection. Oh, sorry, the SSH. RDP is a different connection. But from the client to the Linux with SSH. Now we're going to show you traffic going through to the internet. What I did here, by the way, I created a terminal server on Azure, just my environment. But this is on Amazon, this is on Azure, and I'm going to connect from the Windows machine to the terminal server on Azure, so that's public IP address, over the cluster. So just showing you that it's possible to connect. And once again, we're going to show you the logs. Here it is, remote desktop, and it's approved. And if you're looking, if you guys are technical, if we want to see the cluster state, so first you can see this is the gateway. You can see that its interfaces are 10.0.2. And you can see the cluster is active. This is something we did not conversate, but we can later if you like. but doing a Geo cluster is actually deploying active-active cluster. It doesn't work as active-active. We can talk about it. I'm taking one of the gateways down. I want to see what happens to the RDP connecting through the internet. It was disconnected, but you saw how quickly it was restored. Well, if you ask our guys in QA, R&D, they will say 3 seconds. I want to be careful and say 5 seconds. Why do I want to be careful? Because that's me. But at 5 seconds, it's amazing to do a failover. And you can actually see the logs of the failover, and you can see one of them is still down because we took it down to make the failover. And basically speaking, this is also showing how it's configured on the smart console. So this is the right, you see active-active, that's a new feature by RD40. This is a setup that sets how frequent do you want the updates to sync the connections between the gateways. And you can see that there is no VIP to the cluster, 0000. There's no VIP. The reason is it's an active-active. Each one of them can get connections, and they will sync the connections, so each one of them can get connections from that were coming to the other one. This is pretty amazing. And let's see if the last thing that we want to show. It's just this slide of the end. Okay, let's move on. So an updated construct, if you remember the initial one with north and south, there's now an option, and some customers, like I said, they utilize and they will create multiple hubs. Why would you do that? It allows you to have greater segregation, greater control of the traffic. Because in this updated construct, traffic from the internet will be coming from the inbound hub, hitting a cluster, not a cluster, but this is actually high availability auto-scaling, because most of the connections coming from the internet are HTTP, HTTPS. We don't need any sync between gateways. So we're actually using the auto-scaling. This is Amazon, so we're using auto-scaling groups by Amazon. And if you need more performance, more gateway will be added automatically. You don't need to do anything about it. And when there's no load, gateways will be shut down and taken off. You're only paying for what you're using. So this is very efficient, very scalable, very efficient, and no synchronization needed. It's fine. On the outgoing hub, we've actually created a new deployment option with the transit gateway. So we're talking about auto-scaling group. Again, we're taking advantage of using the auto-scaling capabilities. Again, fully dynamic, fully elastic. And each one of the gateways forms a connection with the transit gateway. And traffic going to the internet also enjoy the benefits of auto-scaling. And again, usually there is no need for synchronization in this cluster. If you do, we can talk about it, how to do it. But basically, there's one more piece that we didn't touch in this design, and that's the east-west traffic. So what happens for traffic going from this VPC to that VPC? You can scan it here, but then because this design has a specific connection to each gateway, which is perfect for outgoing traffic, I think it's less than perfect for east-west traffic because it requires to do source NAT. And source NAT inside the network is not a perfect ideal situation. So in this case, for east-west traffic, you can use the new Geo cluster. There is no VIP. Traffic can flow to either one of them, possibly. Well, it's an active-active, but from an Amazon perspective, it's active standby. We can talk about the details later, offline. But basically, this is a common use case, to have S3 buckets connected directly to my VPC through the hub, the east-west hub. This hub is also responsible for traffic going between VPCs. And outgoing is on its own, incoming is on its own, and the corporate data center. This is where corporate connects with an MPLS. Here it's at the Amazon Direct Connect. It's connected directly to the transit gateway, but it doesn't mean that it's directly connecting to the VPCs, because the transit gateway using the routing domains, you will force it, traffic going from here will be directed to the cluster. No source NAT required, once again, and this is a key thing. And then traffic will flow to the VPC and back. This is how it works. Yeah? Practically, you are using 2 CloudGuard. Actually, I see 3 here. 1, 2, 3. So in this design, there's 3 hubs. Each one of them has CloudGuard in them. And you must be thinking, you guys are smart. You're pushing a lot of CloudGuard to my face. That's not nice. And I agree, right? But not really. The CloudGuard licenses, just so you know, they are by cores. We don't charge you for the number of gateways that you have in the environment. You can have 100, each one with 2 cores, but we don't charge you for 100 gateways. We will charge you just for the cores, right? You don't, well, that's not a good math, but if you're using, let's say that your connectivity requires, by the calculation, you require 50 cores. It doesn't really matter if you put 20 here, 20 here, and 10 here, which is 50 in total. It's the same one if you'd had a big cluster handling incoming, outgoing, and east-west. It's the same thing. Since our license mechanism is fully modular and flexible, you can actually play with it. You can buy a pool of licenses and then assign them as needed. So that's an option. So in my opinion, having 3 different hubs doesn't impact the cost in a big way, because it still is the same cores that you would need otherwise. So yes, you can have 1 hub with 50 cores in our example, or can have 3, this one with 20 because you only need 20 for east-west, this one with 20 because there's a lot of traffic, so you need 20, but this one requires only 10. So that's again 50. It's the same price. You pay the same thing for checkpoint. We don't earn anything because you have 3 different hubs. EC2 price might be higher, but not necessarily, because remember, you have less cores assigned to each machine, and you're paying by the cores, by the CPU. So this is a discussion that we can have, but Amazon, if you deploy more gateways that have smaller footprint, they are cheaper by nature than small machines with higher footprint. So once again, and again, this is it's a big calculation discussion, but it's not black and white. And what I'm trying to say is, in my opinion and in my design, it makes a lot of sense to segregate some stuff. And again, not all customers agree, and it's fine. This is the, usually, and again, this is not a secret, but usually customers using 3 hubs are customers from the finance, banks, insurance, with sensitive. They will be doing VPNs here. They will be doing 3 hubs because they need greater segregation. That's the option, okay? But it's not a must. Let's move on. What can you do on Azure? Because we've been talking about Amazon. So anything we can do on Amazon, we can possibly do also on Azure. So in this example, what I'm going to show you is how a hub, in this example, it's the North Hub. And again, the blueprint is a conceptual approach. It's good for Amazon, it's good for Azure, it's good for Alibaba Cloud. Doesn't matter. It's a conceptual approach, high level. So in this example, I have connected the Azure service, storage service, like the S3 from Amazon, as a service endpoint connected to the hub. And then I have a server connected to Spoke that is going to connect to that storage through those gateways, through the cluster. So let's demo. And again, this is a live demo. I'm taking a risk here. But I think it's a calculated risk. This is my window machine. And this is my IP, my internal IP, 10.3.1.7. So what I'm going to show you is, first, I want to show you that I have no access to the internet, because I want this machine to become only private, internal. So it's not possible to have access. On the other hand, I can actually, do you know about this? This is the Microsoft Azure Storage Explorer. So it allows a client, Windows client, to access the storage on Azure. So what I'm doing here, I go to my storage and file shares, and then inside my files, you can see I have different files. I think this would be the most interesting for you to see. Are you ready for this? Are you? Are you? Okay. So I'll double click. Look, it's downloading it. Who is this? So yeah, this is just an example, of course. This is me during a fun day for Checkpoint. And I dared. I said, yeah, let's do this. This is just an example how the client on Azure connected to the hub was able to access the picture on a storage device, and it's going through the hub. It's not going through the internet. It doesn't have internet connectivity. How do I prove this for you? So here's how I'm going to prove it to you. I'm going to have the management server. This is my management server, and it's connected. And you can see the client accessing a public IP on Azure. So how do you do this? How do you configure that? The way to configure it, here's my rules. It's just an example, but here are the sections that there's. Let me close this so it won't distract you, because there's a lot. So here it is. The client connects, and you can see those objects here. They are a new type of objects. I don't know if you know them, but there's a dynamic object now with R8030 and above. Have you seen it? Do you know what I'm talking about? So you can, just so you know, I can now, instead of using objects from the firewall statically on the firewall, I can click on import. Now there's the option to use the data centers, of course, but also updatable objects. Look at that. So updatable objects, using the updatable objects, I can actually say, listen, I want to use the Azure services. There's 40 of them. And I can actually start restricting specific services. So you can actually say inside your environment, I want to be able to get to S3, but not to get to MS SQL. I don't want to. Or different departments have access to different services. So we're talking about protecting past services from Azure, from Amazon as well, from before I showed you. Being able to control the traffic going to and from the past services. This is something that is, again, maybe it's boring for you, I'm not sure, but it's very, very interesting to a lot of our customers. And so possibly I can then drill down to any of them. So by the way, as you can see, this is not just about Azure. I can actually open up the Amazon Web Services. I can restrict access to API gateways, the CloudFront, whatever. This is different than what we did before, because this service, the dynamic object service, is not using DNS. This is a different way that we took from R8030 and on. It's using a JSON file that is updated constantly by the vendors. We just tap into that, and we are the most up-to-date, have the most updated information about the services, even to the smallest details of allowing S3 bucket from a specific region. I can say, I want to be able to access S3 bucket, but only in Singapore. Why? Because this is what my organization like. But I don't want them to allow access, even by mistake, going to S3 bucket in America. This is not an option. I don't want that. So this is, and yeah, I did show you the logs. Anything else that I missed here? Another thing, just so you know, the same way that I connected service endpoint to my Azure hub, I can also connect private links. Again, I can go on and on forever, but this rule right here is talking about private links. The difference between private links and service endpoints on Azure is that private links, they are actually connect into your VNet. They are actually a private IP within the VNet that you can route traffic to and from it using UDRs. When you're using the service endpoint like I showed you, it's actually going out to the Azure fabric. That's the difference between them. Let's go back to our presentation for the last few words. Well, actually, we have a few more minutes. Let's continue. I have a lot to say. Ooh. So, is it enough? Is it secure if you're using this? What is missing? So how do you protect your storage? Yes, you can connect it using a platform as a service connection, But what about the connections or your S3 buckets that are not connected to the VPCs? What about the storage blobs that are connected to the public? How do you protect them? What about your cloud accounts? The firewall cannot protect your cloud account. They're actually protected by your cloud vendors. Serverless, keys, messaging queue, services like DNS, CDN, etc. How do you protect that? We have to find a way. So the blueprint, the initial design of the blueprint was not, well, it's good while you're using the network on infrastructure. What if you're using other services that is not necessarily sitting inside your VPC? For this, we have Dome 9. For this, I wrote Blueprint 2.0. You're going to have a link to download it at the end of this presentation. But basically what it's doing is if you have an environment, and yes, you are using CloudGuard IaaS to protect the data plane of that environment, protect your assets on your spokes. It's great. But you're adding Dome 9, and Dome 9 is not an agent-based. It's a SaaS solution that we host. And Dome 9 connects to your account, whether it's Amazon Azure or Google Cloud, using API calls. Dome 9 sees everything from a configuration perspective. If you've been in the previous session by Marina, you'd learn a lot about Dome 9. But nowadays, we even have Logic. And Logic allows us to do some big data analysis of the traffic. And we're talking about both flow logs traffic going from a network security group's perspective, but also from a cloud activity log, API calls, those cloud tray logs. And we're combining logs coming from Threat Cloud, so we have a lot of IOCs, a lot of information we can base our decisions on. And we're going to add, we already have that, but on each one of those we will have the geolocation so we can tell where it's coming from. We can combine those two co-work with each other so we have information from Dome 9 accounts. Anything we can see from a configuration, compliance perspective is also shared with Logic. And then we have a couple of ways to do with this. We found something. We saw something that was inappropriate or not needed, and we can take action. The action could be an email, forward to SIM, open a ticket, submit a ticket with ServiceNow, auto-remediate. We can actually take automation actions to remediate the situation. And we can do some threat hunting because we can see a lot of information. This is what it is. And so when we're talking about combining those two solutions together, it's the blueprint, the initial design, as well as someone from above, the Dome 9, so actual dome, protecting the things that are outside of this. Summary. So obviously, what we talked, there's a lot of risks moving to the cloud. Sometimes you don't even know what you're exposing, how risky it is, what's the issue could be, so you should be aware. It's possible to secure. We have the tools, we have the knowledge. Knowledge is not just about, okay, our product is best. Like I showed you, there's a lot of good practices to do, and we'll share with it. And you should, if you are the security guy within your organization, you should be enabler, not the blocker. Our game as security experts has changed. We are now being measured how well we allow the business to run while doing our job. This is really challenging. We understand that at Checkpoint. We want to try and help you. This is why we built this blueprint design. You can download the updated document. There's actually a the first version is available and publicly available on Google if you look for it. So it's not on Google, it's on Checkpoint, but you can find it on Google. The second one, you need to use this QR code and then download. You will need to register, obviously. We want to understand who you are, and it's a gated version, but I think it's worth it. So there's other topics around this, so like the topic I had before and the topics we'll have tomorrow as well. So if you have the app installed, use it to find more sessions around securing cloud. And other than that, it was a pleasure for me, really big pleasure to be here again and again. I'm always welcoming your inputs, so feel free to approach and keep enjoying CPX. Thank you, guys. And I'm leaving this QR code for you if you want to still use it if you haven't downloaded it.